Let's talk about blockchains. Blockchains are distributed databases and have many more applications than just cryptocurrencies, from digital voting to supporting the next generation of the web's protocols. We've built a few simple components to explain how they work. The first component is the hash function. Hashes are used to uniquely identify some data. It's like a digital fingerprint. Changing the data changes the hash. The second component is a block. The block now uses a block number, a nonce, and the data to compute the hash. Note that changing the data changes the block from green to red. This is because the block is no longer valid. A block is considered valid when its hash is smaller than some target. That is, when it begins with 4 or more zeros. And that's what mining is. Mining is the computational work to find a nonce that produces a valid block. A blockchain, then, is a series of blocks connected by their hashes. Changing one hash affects all the following blocks. And by this means, blockchains resist tampering because altering a block invalidates the rest of the chain, which is computationally expensive to remine. But then there's also the problem of determining consensus. How are invalid chains separated from valid chains? Well, by comparing the last block's hash with all of the other last block's hashes. That is, whichever hash is used by the majority of the peers on the network determines the consensus. So even if a blockchain has valid blocks, if its hashes don't agree with the consensus, the chain is invalid. In conclusion, blockchains are shared distributed databases that use techniques from cryptography to maintain the validity of their state, and they have a wide range of uses that are only beginning to be explored.